Every now and then an idea pops into my head and I don't have the skills or the time to pursue it, so I just kind of file it away to the back of my mind. 8 or 9 years ago, I was learning to repair African drums, things like djembes, dunduns, things like that, and that was the first time I had ever worked with stretched animal hides. Now, looking at the way that these drums are built and the acoustic properties of those skins really reminded me of the way that loudspeakers are built. I mean, a drum head is really just a membrane that vibrates and pushes the air around to make a sound. If you could control that electrically, then you would have a loudspeaker. And I think a loudspeaker made from animal skins and wood would have a really unique tone and a really unique look, which I think lends itself to this sort of rustic, mystical, otherworldly aesthetic. I finally had the time to explore this idea earlier this year when I started building a set of stereo speakers in the style of hand drums. Of course, building a single pair of speakers wasn't enough, so I wanted to try building a bunch of different shapes and sizes. And after a lot of experimentation, I ended up with 4 sets, basically, of speakers. And what do you do with 4 sets of speakers? Well, if you work at SparkFun, you turn them into network music players. Each of these music players is equipped with a pair of goatskin loudspeakers, each one being driven by our mono amp breakout board, which makes more than enough power to get these speakers talking. Those amps are connected to the headphone output of a Raspberry Pi, which is configured as a Max 2-play network audio player. All of the Raspberry Pis can be controlled remotely from a Logitech media server on the same network and play music either individually or in unison as a synchronized system. Think of them as sort of a Gilligan's Island Sonos system. To build the drums, I start by cutting a template on the laser cutter. This template is used to maintain a consistent width and miter angle as I cut the staves. The staves are cut from red oak and glued together using premium wood glue and rubber bands for clamps. After the drum shells are dry, I sand the outside down to a more circular profile. Finally, a coat of dark stain and paste wax protects the drum shells from moisture. The drum skin is retained with steel rings, which I've made out of plain steel bar from the hardware store. The rings are formed by hand using the drum shells as a template and then welded closed. Then I grind and polish them with a wire wheel. The bottom ring gets wrapped in vinyl tape to protect the drum skin, and the top ring gets a coating of gun blue to darken up the steel and help it resist rust. I drill a circle of holes in the drum shell and pound in some cut steel masonry nails to act as anchors for the ropes that are going to be used to tension the drum. And now it's time to put the skin on. I bought these goatskin drum heads on Amazon, and they were shipped from Pakistan, which is where a lot of these tend to come from. They arrive as a dried processed skin cut roughly to the diameter of the drum. In order to make the skin soft and stretchy, you need to soak it in water. After soaking, the goat skin feels less like paper or vellum and more like a cloth or a rubber material. I lay the bottom ring on top of the soaked drum skin and then fold the skin around it. Since there isn't a lot of extra skin to work with, I have to tape it down so it'll stay put for the addition of the top ring. With the skin positioned between the 2 rings, I sit the whole thing on top of the drum shell and start weaving in my tension lines. The drum skin will stretch over the shell as I work my way around, adding tension to the ropes. Once it's tied off, I allow the skins to dry, which will tighten them up even further. Now that the drums are complete, they need to be turned into loudspeakers. Loudspeakers work by repelling and attracting a voice coil to a permanent magnet. And the voice coil is connected to a large membrane that vibrates in concert with the electrical pulses in the coil. To get the size of the coil right, I wrap them over a magnet using 30-gauge magnet wire. I use the resistance of the wire and the circumference of the coil to calculate how many turns it would take to reach a resistance of about 6 ohms, which I estimated to be roughly equivalent to the 8 ohm impedance over the certain audio range. I chucked the magnet into my cordless drill and then used it to wind the coils on a cylinder of goatskin. Then I glued them as close to the center of the drum skin as I could get it with a little hot melt glue. The final step to making these into speakers is to mount the permanent magnets. I used massive, half-inch thick, 2-inch diameter neodymium magnets. Yes, I've managed to hurt myself with these a few times, but my hope was that I could compensate for the lack of good field shaping with brute force. I mounted the magnets inside the coils using some steel flat bar and epoxy glue. This process is more or less the same for all of the speakers I built, except for a few of these where I replaced the tension ropes with bolts and washers. While all of the speaker sets look very different, the electronics are all identical. The speaker is driven by a mono amp breakout board, as I mentioned before, and that's wired to the headphone output of the Raspberry Pi. The power to the amp stage can be switched on and off using a MOSFET control board, which I'm switching with a SparkFun red board. The red board controls the RGB power light in the crystal and switches the amp power based on touch events from a design feature on the front of the unit. I made these touch switches by soldering a length of wire to these Coptic crosses and then connected them to one of our SparkFun capacitive touch breakout boards. Setting up the Raspberry Pi to run as a network audio player is incredibly simple. Just download the Raspberry Pi disk image from the Max2Play website and flash it to an SD card. Insert the SD card into a Raspberry Pi connected to your home network, and navigate to the configuration page for that Pi from any computer on that network. From this configuration page, you can give your audio player a name to distinguish it from others on the network, and you can also do things like upgrade the firmware, install plugins, just general configuration. To play music from your Max2Play audio player, just install Logitech Media Server on any computer in the network. When you launch the web player, your audio player modules should pop up in the list of devices. Just select your device and play some tunes from your library. If you're building a Raspberry Pi stereo system of your own, I'd encourage you to look into an external DAC or digital to analog converter, and that'll get you a higher sound quality. Now, a USB DAC can be got pretty cheap on something like Amazon or eBay. Just do a quick search for USB DAC. Now, I didn't bother with this project, I just used the audio from the headphone output because any gain that I would get in audio quality, I would probably lose in my unconventional speaker construction. Anyway, I hope you liked this project, and I hope that it inspired you to go do something really unique. Remember, electronics don't always look like your iPod or your laptop or your tablet, and sometimes they're even more interesting outside of that context.